Good morning, students. So now in this class, we are going to talk about encryption. Okay. In previous class, we have studied about security concept. That is, what is a security? What are the various types of attacks? That is, active attack and a passive attack. And what are the various program threats like Trojan horse? And then next one is logic bomb, trapdoor, stack, and buffer overflow, and viruses. All these are the program threats. Whereas coming to system threats are system and network threats, like worm and denial of service. Okay, all those are the system and network threats. In this class, purely we are going to concentrate on encryption and what is symmetric encryption and what is asymmetric encryption. Okay, how we are going to implement this asymmetric encryption, all those things in this class we are going to learn now. Okay, next, whereas coming to first one is generally here first concept is cryptography as security tool. See here, what is meant by cryptography? Okay, cryptography means simply we can say crypto is nothing but a secret, graphy is nothing but writing. Okay, secret writing we can say it is a cryptography. See, the technical term of cryptography is nothing but, why we are using this cryptography is whenever there is a network, that in that network the sender want to send the information to the receiver. As a matter of fact, if we want to provide the security, definitely we are going to use the concept called as cryptography. Without cryptography, we can't send the data securely from sender to receiver. Here, within a given computer, the transmittal of message is safe, reliable and secure because the OS knows exactly where each one is coming from and where it is going. On a network, however, things are not so straightforward. A rough computer or email, we can say sender, may spoof their identity and outgoing packets are delivered to a lot of other computers beside their final destination, which brings up two big questions of security, that is trust and confidentiality. See here, in the trust is nothing but how can the system be sure that the message received and is really from the source that they say they are, and can that source be trusted? It means trusted means the receiver will receive the data from the sender, means the sender should be trusted one. Okay, if it is trusted one only, the receiver will feel that the data, whatever data I am receiving is a trusted sender, that is sender only. If it is trusted means, then the receiver will feels that actually the data whatever received by the receiver is from the correct source only. Okay, whereas next one is confidentiality. Okay, confidentiality means whatever the data sent by the sender, it should be received by the receiver only. Nobody should view the data in the middle. Okay, that means whatever data sent by the sender, the data can be viewed, the data can be received by the receiver only. There is no other person can't view the data in between sender and receiver. Here we can say, how can one ensure that the message is sending or received only by the receiver? Whatever data sent by the sender, that should be received only by the receiver itself. Okay, this is nothing but confidentiality. Here, cryptography can help with both of these problems through a system of secrets and keys. In the former case, the key is held by the sender so that the receiver knows that only the authenticate other could have sent the message. In the later, the key is held by the receiver so that the only intended recipient can receive the message accurately. Here, what will happen is, whatever data sent by the sender, what will happen? The sender will use one key that same key used by the receiver by getting the data, whatever sent by the sender. Keys are designed so that they cannot be divided from any public information and must be guaranteed carefully. Okay, generally here we are using two keys, that is a private key and public key. Here the concept of key is nothing but whenever the data sent by the sender, here what the sender will do is, sender will encrypt the data, whatever data he wants to send, he will encrypt the data by using the key, and then it will send it to the receiver. At the receiver side, what will happen is, the receiver will decrypt the data by using the same key which was used by the sender. Okay, in order to get the actual data sent by the sender. Okay, here we are using key. Key is nothing but whatever the key which was used by the sender, the same key is used by the receiver in order to get the message that is coming from the sender. Okay, so these two are the issues. Okay, whereas coming to next one is encryption. Okay, here the concept of why we are using encryption means whenever if you want to send the data in a network securely, then there is no no matter of that thing, that is if we provide the encryption, then only we can say that that network should be a secure. Okay, here what will happen is in the sender side, first the sender will take the plain text. Okay, the sender with the help of the plain text, he will encrypt the plain text. After encrypting from the sender side, it will get ciphertext. Okay, we can say M is the plain text. Here, first thing is the sender first create the message M, that is in plain text. Here M is the plain text. That means the sender wants to send the message M. Here M is nothing but plain text. What this M will do is the sender will encrypt the plain text with the key. Okay, after performing the encryption, the sender side, what will happen is that means plain text after encryption, it will generate the ciphertext. Okay, so in between the network sender and receiver, we have ciphertext. So after sender side, after performing the encryption, we have ciphertext. Here ciphertext will give to the receiver side. At the receiver end, what will happen is there the receiver will decrypt the ciphertext, the key which was used by the sender. Okay. So automatically after decrypting, the receiver will receive the original plain text M. Okay, here the sender side will perform the encryption. At the receiver end, we are going to performing the decryption. Okay, encryption is nothing but simply, okay, plain text, we are going to perform the encryption for the plain text with the help of the key. Okay, after performing the encryption, we are going to get the ciphertext. The ciphertext we are giving to the receiver side. At the receiver side, the receiver will take the ciphertext, and what will happen? It will decrypt the data. Automatically after decrypting, it will get the original message. Okay. So this is the first point. And second point is the message is then entered into the encryption algorithm E along with the encryption key KE. Okay. Here what will happen? The original message is M. Okay. We are what we are going to performing is, we are going to performing the encryption with the help of the key KE. For that one, we are going to use the encryption algorithms also. Okay, we have some algorithms like DES, RES, like that. Okay, so here after performing the encryption, it will generate the ciphertext. Okay, ciphertext C equal to, okay, here C equal to E means encryption of with the help of the KE. KE means key with the help of the KE, and M means original plain text. Okay, here C equal to E. E is nothing but encryption of key with the plain text. Okay, for any key K, EK is an algorithm for generating the ciphertext from a message. Both E and EK should be effectively computable functions. Okay, here the thing is, here E of K or KE is nothing but key which was used by the sender. Okay, M is plain text. So this is the first 3 points are the sender side. Okay, here what will happen? The sender will encrypt the message with the help of the key. At the sender side, sender will create the ciphertext C. Okay, the C is given to the receiver side. At the receiver end, what will happen? The fourth point, that is, the ciphertext can then sent over the unsecured network where it may be received by the attacker. The receiver, the recipient enter the ciphertext into a decryption algorithm D along with the decryption key KD. Here the recipient, what will happen is the receiver will take the ciphertext C. Again it will perform the decryption with, for the decryption it will use the key, same key. That we can say KD. Of course, for that one where the receiver will use the decryption algorithms. After decrypting the ciphertext, the receiver will receive the actual message, that is plain text M. Okay, so it is nothing but encryption. Here, if you see the representation, here original message M. M is nothing but plain text. Here what the sender side we are performing? We are going to performing the encryption for the plain text. For that one we are going to use the sender used encryption key along with encryption algorithm. Okay. See here what will happen at the sender side after performing the plain text to encryption with plain text. We are going to get the ciphertext C equal to E of K of M. E of K means encryption of key with plain text. Okay, here we are going to get the ciphertext. Okay, ciphertext we are giving to the receiver end. Receiver end, what will happen? Decryption. For decryption, we are going to use the decryption key. Decryption key means the key which were used by the sender side only. We along with the decryption algorithms. Finally, after decrypting, the receiver will receive the original plain text message M and then he will read. Okay. Here, the question was arrives that key exchange is there now. What is the purpose of key exchange? Okay. The key which was used by the sender, the same key was used by the receiver in order to decrypt. For that one only, we are going to use the key exchange. Okay. The key which was used by the sender for encryption, the same key only used by the receiver for decryption, then only he will get the original plain text. Okay. Here what the attacker means, there is a possibility of attacking the cipher text only. Okay. So this is the representation of the encryption and decryption. Okay. So here next one is symmetric encryption. There are two types of encryptions are there. First one is symmetric and the second one is asymmetric. Here asymmetric means symmetric. What is the difference between symmetric and asymmetric means? Generally, if you are using only one key for encryption and decryption, then we can say it is symmetric encryption. Okay, that means for the entire network encryption purpose and as well as decryption purpose, we are going to use same key. Then we can call it as a symmetric encryption. If it is asymmetric encryption means for the encryption we are going to use one key, for the decryption we are going to use another key. Okay, so if you are using two different keys for encryption and decryption, we can say it is a asymmetric encryption. Whereas a symmetric means if we are going to use the same key for the both encryption and decryption. Okay, with the symmetric encryption, the same key is used for both encryption and decryption and must be safely guarded. There are a number of well-known symmetric encryption algorithms that have been used for security. We are going to use there is various number of security algorithms. There is first one is we can say DES, that is data encryption algorithm, which was developed by National Institute of Standard, that is NIST, has been standard. It is a standard encryption algorithm. In this one, messages are broken down into 64 chunks, each of which are encrypted using 56-bit key through a series of substitutions and transmissions. Okay, here in this DES algorithm, we have totally 60. We are going to divide the message into 64 bits chunks. Each one is encrypted by using 56-bit key. DES is also known as block cipher because it works on the block of data at a time. Unfortunately, that is vulnerability if the same key is used for an extended amount of data. Therefore, an enhancement is not only encrypt each block but also to XOR it with the previous block in a technique known as cipher block chaining. Whereas as a modern computers become faster and faster, the security of DES has decreased to where it is now considered insecure because its key can be exhaustively searched within a reasonable amount of computer time. An extended, enhanced version of DES is called triple DES. That encrypts the data 3 times using 3 separate keys. Okay, triple DES is also a symmetric algorithm. Next, we have one more algorithm, that is AES, that is Advanced Encryption Standard Algorithm, that is AES, developed by NIST in 2001 to replace DES. It uses the key length of 128, 192 or 256 bits and encrypts a block of 128 bits using 10 to 14 rounds of transmission on a matrix formed from the block. Next, one more algorithm is the Blowfish algorithm. It uses variable key length up to 256 bits and works on 128 bit blocks. And next, one more symmetric algorithm is RC5. It can vary in key length, block size and the number of transmissions and rounds on wide variety of CPUs using only basic computations. And next one is RC4 is also one of the symmetric algorithm. RC4 is a symmetric cipher, meaning it acts on a stream of data rather than blocks. The key is used to seed a pseudo-random number generator which generates a key stream of keys. Okay, all these are the various symmetric algorithms. Okay, next coming to asymmetric encryption. Okay, in this asymmetric encryption means we are going to use different keys. With asymmetric encryption, the decryption key KD, we can say KD is not the same as encryption key KE, and more importantly cannot be derived from it, which means the encryption key can be made publicly available and only the decryption key need to be secret. Here encryption key, okay, whatever the key that was used by the sender, the encryption key should be public. That is, from the sender side we are using public key. At the receiver side, that means decryption key need to be kept secret, okay, or vice versa, depending upon the application. Okay, sender side is public, receiver side is private, or sender side is private, receiver side is public. That means we are going to use 2 different keys. Okay, why? Because it is asymmetric encryption. One of the most widely used asymmetric encryption algorithm is RSA, that is Rivest Shamir Adelman. Okay, here this is the representation of the RSA. Here the simple thing here, what will happen is the original message 69. We are going to perform the encryption for 69. We are going to get the 62. For 62, the receiver will perform the decryption. Again, for 62, we are after performing the decryption, finally we are going to get the 69. But in RSA algorithm, what it will happen is, initially we have 69, that is the original text. See here, we are going to get the ciphertext C equal to M power E mod N. Here we are going to calculate 2 values, E and D. Here n, mod n means n value is 91. Okay, after calculating the E, D, n values, we are going to generate the ciphertext. Here, what is the formula for ciphertext? Ciphertext C equal to M power E mod n. Here, M, how we are going to get M, C equal to M power E mod n means, here, what is the value of M? M is the 69, that is plain text, 69 power, what is the E value? E value is 5, mod n, n value is 91. So what is the C value? C equal to 32. Okay, so the formula for ciphertext C equal to M power E mod n. Okay, M is the plain text. What is the E value? E value is 5, n is the common value, that is 91. So after performing the ciphertext, what is the ciphertext value? 62. Okay, again for decryption. Decryption means after decryption, what we are going to get? Plain text. Okay, that is formula M. Plain text means M. How we are going to get the plain text? M equal to C power D mod n. Okay, C power D mod n. What is the C value? Here C is equal to 62. 62 power. What is the D value? D value is 29. So C power 29. That is C power D mod n, that is 62 power 29 mod 91. Okay, so finally we are going to get the 69 value. Okay, so this is the RSA algorithm. Okay, in this way we are going to provide the security by using the RSA. Next we are going to talk about authentication. Okay, here next topic is user authentication. Authentication plays an important role in security. It is one of the major issues associated with the operating system. There are three different kinds of authentication mechanisms are there. First one is password based, second one is artifact based authentication, next one is biometric based authentication. See, whereas first one is, it is a simple user ID and password combination. For example, we have user U1 and the password of user U1 is 123. Now, whenever this user wants to enter into the operating system, then operating system asks username and password. Then user enter username U1 and password 123. Then operating system checks this username and password in the database stored inside the operating system files. If the match is made, then success is written from the database. Then operating system will grant access to that user. Now, if the user enters wrong password, then database return false. That time the user not allowed to enter into the system. The problem with the password mechanism is that normally passwords are stored in plain text. So, if attacker may easily access the database, gaining all usernames and passwords. Okay. Here the password policies are: a password is one that easily to remember but difficult to guess. And the password should not be dictionary words, proper nouns or foreign words. At the same time, passwords should be a mixture of uppercase and lowercase characters along with numbers. Okay. And next one is artifact based authentication mechanism. In this one, it includes machine readable strips or magnetic strips, and this can be smart cards or debit cards, or we can say credit cards. The next one is biometric based authentication. It is considered as one of the most secure authentication mechanism. It uses two different characteristics of human, that is psychological, next one is behavioral. The drawback of this one is costly and it intrudes the privacy of the user, because all behavioral and psychological characteristics of the user recorded in the system, but it is still considered as most secured authentication mechanism. Next, coming to implementing security defenses. In this one, we are going to know about security policy. A security policy should be throughout agreed upon and contained in a living document that everyone adheres to, and it is updated as needed. Example of contents includes how often port scans are run, passwords, requirements, virus detectors, etc. Next one, we are going to know about intrusion detection. Okay, here intrusion detection attempts to detect attacks, both successful and unsuccessful attempts. Different techniques vary along several axes. First one is the time that detection occurs, either during the attack or after the fact. Second one is the type of information examined to detect the attacks. Some attacks can only be detected by analyzing multiple sources of information. Next one is the response to the attack, which may range from alerting an administrator to automatically stopping the attack. Another approach is to divert the attack to a honeypot on a honeynet. The idea behind the honeypot is a computer running normal services, but which no one uses to do any real work. Such a system should not see any network traffic under normal conditions. Okay, so there are two major approaches to detecting problems. Okay, first one is signature based detection, and next one is anomaly detection. Okay, these two are the two major approaches to detect the problems. What is meant by signature based detection? It scans network packets, system files, etc., looking for recognizable characteristics of known attacks, such as text strings for messages or the binary code for exec bin sh. The problem with this is that it can only detect previously encountered problems for which the signature is known, requiring the frequent update of signature list. Whereas coming to anomaly detection, in this anomaly detection looks for unusual patterns of traffic or operation, such as unusually heavy load or an unusual number of logins late at night. So next topic is firewalling to protect systems and networks. Firewalling to protect systems and networks. Here firewalls are devices, sometimes softwares, that sit on border between two security domains and monitoring log activity between them, sometimes restricting the traffic that can pass between them based on certain criteria. For example, a firewall router may allow HTTP requests to pass through to a web server inside a company domain while not allowing telnet. A common architecture is to establish a demilitarized zone, DEMZ, which sort of sites between the company domain and the outside world, as shown in the figure. Okay, perhaps most importantly, the DMZ cannot reach any of the other company computers. So even if the DMZ is breached, the attacker cannot get the reset of the company network. Okay, so here the example of firewall to protect system and network. Okay, here firewalls themselves need to be resistant to attack and unfortunately have several vulnerabilities. Tunneling, which involves encapsulating forbidden traffic inside of packets that are allowed. Denial of service attacks addressed at the firewall itself. At the same time, spoofing, in which an unauthorized host send packets to the firewall with the return address of the unauthorized host. Okay. So next, coming to one more topic, that is computer security classifications. Okay, in these computer security classifications, no computer system can be 100% secure, and attempts to make it so can quickly make it unusable. However, one can establish a level of trust to which one feels safe using a given computer system for a particular security needs. The US Department of Defense Trusted Computer System Evolution Criteria defines 4 broad levels of trust and sub-levels in some areas. That is level D, level C1, level C2, level B, level B2, at the same time B3, like this. Okay. Whereas level D is the least trustworthy and encompasses all systems that do not meet any of the more stringent criteria. Okay. Disk operating system and Windows fall into level D, which has no user identification or authentication, and anyone who sits down has full access and control over the machine. Like level C1 and level C2. Level C1 means it includes user identification and authorization and some means of controlling what users are allowed to access what files. It is designed for use by a group of mostly cooperating users and describe most common Unix systems. Okay, so these are the some of the levels. Okay, right. Thank you.